Good afternoon to everyone. I think we have been having a series of webinars for the past 3 months during this pandemic, but now we are trying a different option. We thought we would connect to all the members available in the social media. So this Saturday we will be connecting you in this platform. Hope it's going to be an interesting session. We are as interested as you are. So let's straight get into the topic. So today's webinar will cover on the topic of modern pre-hardened steel for injection molding applications. Myself, Stalin Lakshmikandan, and I am handling um, Toolox product for India region. Okay, just straight into the summary. If you ask me what should I expect as an audience from this webinar, I'll just sum it up for you. So we'll be getting into a brief about both Swedish Semi Steel and SSAB, the mill, and we look into how the product Toolox is different from the conventional tool steels and how it's been manufactured and what's the different application does it help you. And since it's been in pre-hardened material, I think everybody will be having their own apprehension about the machining parameters and how it is going to save your time. It's very important. And we'll also look into in comparison between Toolox and conventional steel grades. And we'll also look into various case studies wherein which majorly we'll look into the case studies which involves Toolox used in injection molding applications. Yeah. Okay. Are you guys ready? Okay. So to brief about our company, Swedish Semi Steel. So we supply special steel and complete wear solutions in the Middle East and Indian subcontinent. In India, we are based in Bangalore with offices in Pune and customers spread across the country. Swedish Semi Steel operates under the motto of providing highly local and highly technical service, which we have been given to customer so that only we are in the field for the past 30 years. We have a long-standing relationship with our mill, SSAB. We have a relationship of more than 2 decades. Let's get into what is Toolox. So Toolox is a multi-purpose, ready-to-use engineering steel. It is based on a high-strength, low-alloy concept. So it comes with two grades, Toolox 33 and Toolox 44. And Toolox 33 comes with 30 HRC metal with a toughness value of 100 joules, wherein which Toolox 44 comes delivered at 45 HRC with a toughness of 30 joules. So it has been produced by SSAB, whom are known for producing high-strength steel. And again, we are Swedish Semi Steel, and we are the provider of Toolox in India and Indian subcontinent. And we provide both plates and bars, plates from 5 mm to 165 and bars from 16 mm to 353. So if you look at the product as a whole, I mean, all the mechanical properties which has been listed, Toolox is a product wherein which it has a unique combination of both the hardness, toughness, and the strength values. So it gives you high strength, it is a low alloy concept, so it is easy for you to machine also, even though the hardness is very high. So it is that combination which is pretty hard for conventional steel grades to achieve. So you would find we are the only supplier who is supplying 45 HRC steel with these similar properties in the world. So let's look at how this product is being manufactured. What makes for this Toolox product to get these properties? So let's see how it's been manufactured. Okay, if you look at the manufacturing and to just make it in common terms, so it uses blast furnace. We do not use electric arc furnace. I mean, this is the rolling mill where the slabs come out. And to put it in a nutshell, this is where the entire R&D of the material happens. As you could see that hot slab which rolls out and comes and it turns into room temperature within a matter of seconds. So for different thicknesses of the material, what is the quantity of the water that you use to quench it at different angle determines the property of the material. And this is where the entire R&D structures around. So we have nothing to hide, and this is the process which it, it goes through. It uses water quenching and it is tempered around 590 degrees centigrade. So with all the details, what we have. So what we know that metal is 45 HRC delivered with high toughness and high strength, and you had seen how it has been manufactured. So with these unique properties and the combination what it has, so Toolox is being used widely in various engineering applications. You name it, you plastic molds, cold forming, hot forming, high friction components, other mechanical components also. So today we'll stick only to the plastic molding applications. So we'll see how it behaves with various kind of plastics and how it has helped different customers across the globe to improve their production and to get more life out of this material. So this is a general graph which is in comparison between Toolox 33 and a conventional P20 material. So you'd find that the area of carbides in Toolox 33 is less, comparatively less when you compare to less than P20. So when you have carbides have two functionality. It has a pro as well as has its own con, wherein which the more number of amount of carbides will help you in better friction, but less number of carbides will reduce your friction, but at the same time you will be able to machine easily. So Toolox combination is such that wherein which you will be able to machine swiftly also, but at the same time you will be able to get better wear resistant properties also. So if you're using a regular P20 and if you're going to try Toolox 33, then you can use two things. You can either increase your milling speed for the same kind of machining thicknesses. So you can increase your milling speed by 40%, or you can keep the speed as a constant and you can increase the insert life. Okay, so this is a graph which we have done in our own laboratory. I mean, this is a comparison between Toolox 44 and H13. So the main aim of this webinar is, I mean, everybody has been using pre-hardened tool steel, but compared to the regular P20, P20HH, this is a step further. And it is not only going to replace your pre-hardened version of, I mean, your P20 version, but it's also going to replace, it will also act as a player wherein which you can get a pre-hardened version of your H13 as well as your D2. So here you are comparing Toolox 44, which is delivered at 45 HRC, to an annealed condition H13. So what we get here? So as you can see the manufacturing time, which is given at the y-axis. So you can see the programming time is, you need not do two programming as compared to H13, because at annealed condition also you need to do, again after heat treatment also you need to do another set of programming that is not required here. You can go with one set of programming. You can go for the direct final CNC. You need not go for rough and final. You can directly go for a final CNC. And obviously, the EDM timing is a bit more than compared to your regular H13, since metal is 45 HRC. So having said that, so when you calculate the time required for two manufacturer component A being with H13 and component B with Toolox 44, you would find from raw material to the finished component, you'll be able to save a manufacturing time of at least approximately from 25 to 30%. This in addition to your heat treatment time and heat treatment money that you are spending. So that is a good proponent, right, for you to try this material. What else do you need out of this material? So general P20, P2738, I mean, everybody would be aware, and H13 also would have used in your inserts. Now you have in possibility wherein which not only when P20 you're not able to do your heat treatment, I mean, there is no need for you to do heat treatment, but even in when you're using H13, if you replace it with Toolox 44, which you can very well do it, that then too you do not need to have any kind of heat treatment if your requirement is only 45 HRC, or even you can take it up to 48 HRC. If your requirement is 45 to 48 HRC, there is no need for you to go to heat treatment. You can directly take Toolox 44, delivered at 45 HRC, you can just measure it and put it into use. Fair enough. I mean, for those who are asking, I mean, what will I mean, I have a requirement of 50 HRC or 55 HRC or 60 HRC. What should I do? I mean, whether Toolox is not useful. No problem. I mean, Toolox is, that's why it is an excellent engineering substrate. So whatever kind of injection molding, I mean, surface treatment technologies that you want to inculcate in the material, Toolox will be able to adhere to it. So as you can see, the chemical composition, this we have discussed on the starting itself. It has been in low alloy material, and it has a carbon equivalent of 0. I mean less than 1 when compared to H13 or your P20, which means any metal which is less than 1, the carbon equivalent, then it is very easy for maintenance for all thermal cutting as possible, and you can do the different kinds of welding in Toolox 44 without any issues. So this is the texturing of Toolox 44 when compared to others. Okay. So Toolox been delivered at 45 HRC. I think as we discussed earlier, I mean, everybody would be having the apprehension, okay, how can I machine it? Do I need to look for an expensive tools? Do I need to spend extra money? What I'm trying to save in the heat treatment cost, whether I will be able to I need to invest again in the machine. Not really. And we look at the various machining parameters in which we have tried with Toolox. I think after this machining part of this webinar, you will be able to understand better and how exactly the Toolox can be machined. So for all the mold makers out there, I mean, you would be knowing about Hasco. Hasco is from Europe. So you could just Google Hasco on Toolox. No problem. You could find that Hasco has recommended Toolox in their own brochure. And these are some of the test pieces that they have tried for drilling in Toolox 44. And this is the Hasco test piece that they have tried with 33. So this is what they give you. Say, I mean, if you're a mold maker and if you're taking P20, for example, and you compare with Toolox 33, everybody doesn't seem to understand that even though Toolox is 40% higher in material cost initially, but the total cost when you compare all the machining parameters, machining, stress relieving, and grinding, you would find the total cost after 70 hours of machining. You will find the total cost for Toolox 33 is much lower than what you spend around P20. If that's the case, why would you not try Toolox against P20 or P20 equivalent? So these are some of the Hasco's results for machining of Toolox 44, and they have given various comments on the same. So what they say is milling with average speeds for hard milling is possible. That was a very good behavior of the tooling in thread milling with relatively low tool wear. Even of 30D is possible in long hole drilling. Surface quality is adequate. I mean, when you want to achieve close tolerances, you can trust the material. The test piece was absolutely stress free. That is the important thing that we need to stress upon. Toolox is internally without any stresses. There are no internal stresses in the block. So there are no internal stresses, and that's why even when the tool comes in contact with the material, it doesn't work hard, and whatever stress has been generated comes out of the form of chips. So there is no stress inside the block, and you don't generate any stress during machining. So that you are not you are not required to do any kind of an external stress relieving even when you have in complex machining which is happening with Toolox. That is an additional added advantage to you. And usage of tools for hard milling is necessary. Yeah, you need to use the right tools. That's the which we have been telling from day one. So given the right amount of tooling, the given you set up the right kind of tooling nomenclature, drilling or machining with Toolox 44 is not a big task. Okay, let's see some of the tooling recommendation. This is for turning. So you can find the feed rate and the different kind of insert grades for all three grades of Toolox. And these are tapping recommendations. So we recommend from Toolox, we recommend tapping from M5 and above. If you want to do below M5, we don't recommend tapping. I mean, it's better to go for thread milling. And these are some of the tool recommendations for Toolox. And we have given that various manufacturers for tools also Seco, Cottrell from Seco and Sandvik. So it is not necessarily that you need to go for this tooling suppliers. Okay, fine. We have tested and tried and tested these kind of parameters, whatever we have. So it will be easy for you to straight away use it with these parameters. But if you want to use a different kind of in tooling, then you can ask your present tooling supplier to supply tools with equivalent nomenclature. I think they'll be able to supply. So if you're able to use it the similar kind of products, then also you'll be able to achieve the results. Not required to use expensive tools always to get the required result. So this is an high-speed rough milling where in which we have tried Toolox. So the insert lifetime which is used to mill this Toolox surface, insert lifetime is 180 minutes. The volume of chip removed is 161 centimeter square per minute. The total volume is around 30,000 centimeter square, and it has only very small deformations even after this extensive machining. So the surface quality of that plate is very good. It is very good. That is so that there is no need for you to do extra polishing. So let's look at the traditional milling, what they do over here. So it's not only the expensive milling machines that you need to do. I mean, with traditional milling machines also you will be able to achieve. So this is Walter WKP35S insert, and it has in 0.4 mm deformation on flatness during rough milling. So that also should be an issue. So let's look at in small milling video where in which it's been done. It was done in a tool room in Pune. As you could see, the color of the chips being very bluish, which implies that there are no stresses and it's very smooth for you to machine it. And we spoke about the Toolox being, Toolox carbon equivalent is very less, and we said that it is very useful for very easy for you to maintain the tool, right? So this is another example wherein which it is easy to weld as one part, but it's very, very interesting that you are able to do this kind of gasketing with Toolox material, and it's very, 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 very difficult with traditional tool steels with this. Let's look at this video. So if you find this is in 120 mm, you would not believe this is 120 mm Toolox 33. And if at all you want to do any profile, you can cut it as it is and just machine it on the only the heat affected zone. And if you want to do like, then you need not take in square block and then machine all along. So what you save is the amount of machining involved and the ease in which that you will be able to manufacture these kind of profiles. That's where Toolox really helps you out in various aspects of tool making. So as we discussed earlier, so Toolox is an excellent substrate for surface engineering. So Toolox being delivered at 45 HRC. For those who are asking, okay, fine, I have a mold wherein which my requirement is 50 HRC or 60 HRC, where I require better wear resistance. So what would I do? What should I do? So you can use any of the surface treatment processes. This nitriding, which is high resistant to wear and surface pressures. You can use those from methods. We can use PVD coating. It is also extreme. It has extreme resistance to wear and corrosion. You can do induction hardening as well and laser hardening too. So Toolox being delivered at 45 HRC. So when you do nitriding, you'll find the hardness values increases from 60 to 62 HRC. If you do PVD, it will cross 70 plus in the hardness. So this is a general chart wherein which if you're doing nitriding, the different kind of temperature that you need to maintain and different soaking time for you to achieve surface hardening and the desired hardening depth. You can use this sheet as a reference for you. In induction hardening, it's a combination of so the both combination of induction hardening as well as Toolox 44 is very unique. It is very unique for the simple reason that due to the better yield strength of the material. So some applications obviously require better case depth, and for those kind of applications in which you require better case depth, which in turn improves your corrosion resistance property. So here in induction hardening, you will be able to achieve a hardness of 55 to 57 HRC with a depth of hardness of 2 to 4 mm. So wherever you have your requirement, you want a better depth of hardness, you can use Toolox. So this is Toolox, where in which it provides the real-time data how the metal has been induction hardened. So this is induction hardening which has been conducted in Toolox 33, dia 91. So you can see how the induction hardening process has been done. So laser hardening is also an upcoming surface treatment method, wherein which here we have an example of a bush which has been used in a short blasting machine. So Toolox 44 you can achieve up to 800 HV, which is around 70 plus HRC, and Toolox 33 around 55 HRC. So the thickness of the laser hardened surface, it is anywhere between 0 to 0.2 to 2 mm. Depending upon the application, you can decide what is the thickness of the, depth of the thickness that you try to go. So this is a laser hardened shearing blade, and this shearing blade has a 4-meter long length. So as you can see that you will be able to determine the width of the your laser beam according to your application. So it is very concentrated, so you can decide, you can only do it to the desired location where you want the hardness to be increased. So this is an upcoming technology, but we have certain people available in India too who can do this. Okay, so we have looked at how the Toolox is being manufactured. We have looked at how the 45 chassis steel is being done without any issues using various machining techniques, and we have also looked up on what is the various kind of surface treatment methods available for increasing the hardness of the material. So now we look at how Toolox as in product has improved various maneuvers and various improve the lifetime of different molds for different applications around the globe. Okay, fine. So which grade to choose in molding? So we have Toolox 33 and we have Toolox 44. And you have n number of plastics, name PP, PBS, plastics with glass filled, plastics with filler materials, PC. So for these kind of different kind of plastics, which grade to choose? And whether I need to use nitriding for every product or whether we need to do PVD for every product. I think this would give you a definitive idea, a general overview of for the different kind of plastics what you have in which you're going to do in your tool room. What is the kind of type of metal that you need to choose? You can choose between Toolox 33, Toolox 44, Toolox 44 nitriding for with glass fiber material, and PP and nylon you can use directly Toolox 33 and Toolox 44 respectively. So let's look at some of the application. This is an furniture die. This has been made with Toolox 44. It was replaced with P20HH. The earlier problem of deformation and distortion is solved here. So you can see the amount of polishing that you can get from Toolox 44. And this is a plastic more cover mold which has been manufactured without heat treatment. So Toolox has been taken at 45 HRC and it's been produced and put into use. So no problem. They saved around 1 week in production time alone. And this is in polycarbonate plastic cover for headlight glasses. So you can see that it's for the headlight glass. And Toolox 33 for car motor sealing and front grille for Ford car using Toolox 44. And this is Toolox 44 in a mold for an Audi TT, and all inserts were made in Toolox 44. The previous thickness has been P20HH, and this was especially produced for Audi and supplied. So this is a mold for an injection molding of an automotive security belt guide, and the temperature of this molten plastic during the injection used to be around 220 degrees, and the surface temperature, estimated mold surface temperature would be around 80 degrees centigrade. So elimination of heat treatment was done, which was in benefit to the customer. Manufacturing time was reduced from 25 to 30%, which we already saw during, and total mold cost was decreased from around 2.5 euros per kg. So if you're able to decrease the mold cost around 2 euros, I mean that roughly runs around much 200 to 20 rupees per kg. And if you're able to see per single kg 200 rupees, if you're using a mold where in which 500 kg is required, 200 kg is required, you can look at the savings that the material brings into you in the form of these kind of things. And mold maker experiencing slightly more difficulty with machining, which is understandable. I mean, they'll be able to overcome that in due course of time. And Toolox 44 is used in the mold producing the rear window clamping for the new Porsche. So this is the component which we made. This is from Turkey. So this is a higher polishability which is achieved when compared to P20HH. I mean, these are the lightning parts for low trucks. And this is a cover for motorcycle lamp, headlight lamp, and as always, they saved 1 week time in manufacturing, and they made the full series with excellent results. Nothing to complain. And Toolox 44 the mold for door handle to Fiat. So this door handles was made with Toolox 44, and Toolox 44 is now to choose. Now it's the choice to shorten the mold manufacturing time. And Toolox 44 again been used in central tunnel of Mercedes. And nitride Toolox 44 is used in glass fiber reinforced components. The demand for the mold service life was production of 50,000 components, which was easily achieved. And this is in polycarbonate plastic, wherein which the earlier material was H13ESR. You can find that Toolox has replaced it, but not only that, there is really extremely high machining involved. So the block size was 130 mm and it was machined up to 20 mm at the depth. So which means until the block is pre-hardened throughout the entire thickness of it, and the properties are homogeneous throughout the entire block, you will not be able to achieve the desired results. And that's where Toolox is really giving you all your money's worth. That it is a 45 HRC material which has a unique combination both the high strength as well as high toughness values, and it has homogeneous properties throughout the length and breadth of the plate. So you need not worry about the quality of the material. So conventional 2.2344 would normally be used, which has been replaced by Toolox 44, and 2 to 3 days in heat treatment and 2 days extra wire erosion and machining. This is a plastic mold for spice grinder. So nitriding will be made, polishing much better than P20HH. And this is from China, so the application ranges from where in which people have used previously a star from Japan, which is again a patented material like Toolox. So, but I mean, they used in hardness level of 48 to 52 HRC, which was heat treated and achieved. But wherein 45 HRC is enough with Toolox 44, no additional heat treatment required. So they had warpage and distortion issues after quenching and tempering, and cracks during production runs, and which was not the case with Toolox 44. Toolox 44, which all the properties what this has, it went through all the defects that the customers were complaining about. This is Toolox 44, Toolox 40 plus chrome plating, ABS plastics designed for 5 lakh component. That's another example for Toolox 44. This is test as a plastic mold maker. 2 pieces of 960 by 1 meter was made. So this is another example where in which it is PA60 kind of plastic with 45% glass fiber, and this is after 5 lakh components. There is no problem, no heat treatment involved, and if you're able to get 5 lakh components, I think it's again all your money's worth. Whatever you're spending with Toolox, it does give it to you back in the form of savings, either in the production time or in the total running time of the die. I mean, home appliances for use with Toolox. This is an core side of the kettle mold. This is a glass shelf which is used for Bosch refrigerators, and the weight of the part is around 500 grams, and closing force of the injection press is around 300 tons. And total part being produced is 5,000 to 10,000 components. And this is where Toolox adds to your stability in using this as a material for your tools. So not only that, one thing what you can do is you can use it for your prototypes with Toolox 44. So since it's non without any heat treatment, you can finish it faster. But once you want to get into what you could say, once you want to get into the various parameters which is involved here, then you will be able to give the desired results for the Toolox 44. So this is an hearing aid which is being done, and so all kind of component, not it doesn't Toolox application doesn't start and stop with automobile. It stands. I mean, automobile is the main area of usage, but more than automobile, home appliances, and even in medical equipments, Toolox has been used. Okay, so we have come to the final segment of our webinar. So if you want to summarize what we have gone through, so we have looked at the quality of the manufacturing process, what Toolox goes through. So no heat treatment is required with Toolox, and it saves you money and time. And you can say this is a pre-hardened version of not only your P20, but also for your H13 and D2 inserts. So that is where it is very unique, and that is where it is trying to save you more time. And case studies from across the globe we have looked into, and how exactly it is saving customers time in production or during manufacturing. I think thanks for your patient listening, and we come to the end of this webinar, and now the floor is yours. If you have any questions, I'll be more than pleased to answer it.